students. For today's lesson, we have trigonometric ratios. Trigonometric relationship. There are 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant, and cotangent. These 6 trigonometric ratios are abbreviated as sine, S-I-N, cosine, C-O-S, tangent, T-A-N, cosecant, C-S-C, secant, S-E-C, and cotangent as C-O-T. These are referred to as ratios since they can be expressed in terms of the side of the right angle triangle for a specific angle theta. Using this figure, we have the theta, and then we have as it parts, we have the hypotenuse, yung slant line, and then yung katapat ng ating theta is called the opposite side. Then yung katabing straight line ng ating theta is called adjacent side. Using this triangle, or using the triangle in the figure, to find sine theta, we have opposite over hypotenuse. For cosine theta, we have adjacent over hypotenuse. For tangent theta, we have opposite over adjacent, or it is also equal to sine theta all over cosine theta. For cosecant theta, it is the inverse of our sine theta, so that is equal to 1 over sine theta. That is also equal to hypotenuse over opposite. Secant theta is the inverse of our cosine theta. So that will be 1 over cosine theta, or it can also be hypotenuse all over adjacent. And then cotangent theta is the inverse of our tangent theta, and that is equal to 1 over tangent theta. Or it is also the same with adjacent all over opposite, or cosine theta all over sine theta. Remember this. We have SOHCAHTOA. So means sine, S for sine, O for opposite, and H for hypotenuse. That means sine theta is equal to opposite over hypotenuse. Ka means C as cosine, A as adjacent, H as hypotenuse. So that will be cosine theta is equal to adjacent over hypotenuse. Then TOA, T means tangent, O means opposite, A means adjacent. So that will be tangent theta is equal to opposite over adjacent. The other one is the inverse of sine theta, and that is cosecant theta. Since our sine theta is opposite over hypotenuse, then our cosecant theta will be 1 over sine theta, or hypotenuse over opposite. Next one is the inverse of cosine theta, which is the secant theta. So that will be 1 over cosine theta, or since our cosine is equal to adjacent over hypotenuse, so for secant theta, that will be hypotenuse over adjacent. Last one is the inverse of tangent theta, which is the cotangent theta. So that will be cotangent theta is equal to 1 over tangent theta, or since our tangent is equal to opposite over adjacent, then our cotangent will be adjacent over opposite. Let's proceed now with our examples. Given this figure, let's find the 6 trigonometric ratios. For the solution, we have the sine theta, which is opposite over hypotenuse. Our opposite is equal to 2, and hypotenuse is equal to 6, so that will be 2 over 6. By simplifying this one, we'll have 1/3. That means our sine theta is equal to 1/3. Cosine theta is adjacent over hypotenuse. Our adjacent is 4 and hypotenuse is 6, so that will be 4 over 6. And to simplify this one, we'll get 2 over 3. That means our cosine theta is equal to 2 over 3. For tangent theta, we have opposite over adjacent. Our opposite here is 2 and our adjacent is 4, so that will be 2 over 4. Simplifying this one, we'll get 1/2. For cosecant theta, that is equal to 1 over sine theta. So that will be, since our sine theta is 1/3, so that will be 1 over 1/3. And that is also equal to 1 over 1 multiplied to 3 over 1. 1 times 3 is 3. 1 times 1 is 1. So that will be 3 over 1. 3 over 1 is equal to 3. That means our cosecant theta is equal to 3. For secant theta, that is 1 over cosine theta. Our cosine theta is 2/3. So that will be 1 over 2/3. And that is also equal to 1 over 1 multiplied to 3 over 2. 1 times 3 is 3. 1 times 2 is 2. So that will be 3/2. Our secant theta is 3 over 2. For cotangent theta, that is 1 over tangent theta. Our tangent theta is 1/2. So that will be 1 over 1/2. And that is equal to 1 over 1 times 2 over 1. 1 times 2 is 2. 1 times 1 is 1. So we'll get 2 over 1. And that is equal to 2. So our cotangent theta is equal to 2. Another example, this figure. Our hypotenuse here is 5, adjacent is 15, and opposite side is 10. Let's find out the 6 trigonometric ratios. For the solution, we have sine theta as opposite over hypotenuse. Substitute, our opposite is 10 and hypotenuse is 5, so 10 over 5, and that is 2. Cosine theta is adjacent over hypotenuse. Our adjacent is 15 and hypotenuse is 5. 15 divided by 5 will get 3. For tangent theta, we have opposite over adjacent. Substitute, will get 10 over 15. Simplifying this one, we'll get 2/3. Next, cosecant theta is 1 over sine theta. Since we have sine as 2, so that will be 1 over 2 or 1/2. Secant theta is 1 over cosine theta. Our cosine theta here is 3. So that will be 1/3. Cotangent theta is equal to 1 all over tangent theta. Our tangent theta is 2/3. So that will be 1 over 2/3. And that is also equal to 1 over 1 multiplied to 3 over 2. 1 times 3 is 3. 1 times 2 is 2. So cotangent theta here is equal to 3/2 or 3 over 2. Another example here is this one. This time, nasa baba ang ating theta. So, our hypotenuse is 9, opposite side is 18, and adjacent side is 27. Let's find out the 6 trigonometric ratios. So, again, for sine, so, that is opposite over hypotenuse. Substituting, we'll have 18 over 9, and 18 over 9 is equal to 2. Next one is cosine. Adjacent over hypotenuse. Our adjacent is 27 and hypotenuse is 9. 27 divided by 9 will get 3. Third one is tangent theta. Opposite over adjacent. Our opposite is 18 and adjacent is 27. Simplifying this one, will get 2 over 3. Since they are both divisible by 9, divide them both by 9, you'll get 2/3. Cosecant theta is the inverse of sine theta. So, 1 over sine theta. Our sine theta here is 2. So, that will be 1 over 2. Secant theta is the inverse of cosine theta. That will be 1 over cosine theta. Our cosine theta is 3. So, we'll get 1/3. Cotangent theta is the inverse of tangent theta. We get tangent theta as 2/3. So, that will be 1 over 2/3. And that is also equal to 1 over 1 multiplied to 3/2. 1 times 3 is 3. 1 times 2 is 2. So, we'll get cotangent theta as 3 over 2. For the last example, we have this figure. 7 is our hypotenuse, 21 is opposite side, and 14 is our adjacent. Let's find the 6 trigonometric ratios. Again, for sine, opposite over hypotenuse, substitute 21 over 7. 21 divided by 7 will get 3. Next is cosine theta, which is adjacent over hypotenuse. Substitute, will get 14 over 7. 14 divided by 7 will get 2. Next is tangent theta, opposite over adjacent. We'll get 21 over 14. Simplifying this one, we'll get 3 halves since they are both divisible by 7. Cosecant theta is the inverse of sine theta, 1 over sine theta. Our sine theta is 3, so we'll get 1/3. Secant theta is the inverse of cosine theta. We'll get 1 over cosine theta. Our cosine theta here is 2, so we'll get 1/2. Cotangent theta is equal to 1 over tangent theta. Our tangent theta here is 3 halves, so we'll get 1 over 3 halves. And that is equal to 1 over 1 multiplied to 2 over 3. 1 times 2 is 2, 1 times 3 is 3, so we'll get 2/3 as our cotangent theta. Okay, that's all for today. Thank you for listening. God bless.